Even while circuits with just one battery and one load resistance are very easy to evaluate, real applications do not frequently use them. Typically, circuits consist of more than two connected components. More than two circuit components can be connected in either series or parallel, which are the two fundamental connections. Circuit with series configuration. Here, a long chain of three resistors, designated R1, R2, and R3, is linked from one battery terminal to the other. It should be noted that the numbers in the subscript labeling, to the lower right of the letter R, have nothing to do with the values of the resistors in ohms. They merely help to distinguish one resistor from another. There is just one path for current to flow, which is what distinguishes a series circuit from other types. The current in this circuit moves clockwise from point A to point B, then to point C and D, and then back to point 1 again. Circuit configuration in parallel. We have three resistors once more, but this time they create many uninterrupted current paths. There is only one route from A to B, G to H, and back to A. Another one goes from A to B to C to F to G to H before returning to A. A third route leads from A to B to C to D to E to F to G to H and finally back to A. A branch is any distinct route via R1, R2, and R3. The fact that all components of a parallel circuit are connected to the same set of electrically common locations is what distinguishes it from other types of circuits. We can see from the schematic diagram that electrically common points A, B, C, and D are all together. Points H, G, F, and E are also true. Keep in mind that the battery is connected between these two groups of points, along with every resistor. Circuit with a series parallel configuration. In this circuit, the current can move through two loops. One that goes from A to B to E to F and back to A, and another that goes from A to B to C to D to E to F and back to A. Note how R1 is traversed by both current pathways, from point A to point B. In this configuration, R1 is in series with the parallel combination of R2 and R3, whereas R2 and R3 are said to be in parallel with one another. The fundamentals of parallel and series connections. In order to create a single path for current to flow, components in a series connection are often connected end to end in a line. On the other hand, the fundamental concept of a parallel connection is that all components are linked across each other's leads. No matter how many components are linked, there can never be more than two sets of electrically common points in a circuit that is strictly parallel. There are numerous paths for current to travel, but all components share a single voltage. All of the parts of a series circuit are attached end to end, creating a single path for current flow. All of the components in a parallel circuit are linked across one another to create precisely two sets of electrically coupled points. A path for electrical current created by one of the load components is referred to as a branch in a parallel circuit, such as a resistor.